I'm going to talk about the process for coming up with the graph of a quadratic equation that's in vertex form. What you need to know is one-step and two-step algebra. You need to be able to substitute values in for variables, know how to plot points, be familiar with graphing linear equations and graphs of quadratic equations in general, and being able to uh, identify the characteristics of quadratics. Let's consider this equation y equals 2 times x minus 3 squared minus 8. It's following this form y equals a times x minus h squared plus k. This is vertex form of a quadratic. We know it's a quadratic because we've got a squared here on our x term. This is going to result in an x squared. And this a value in front, in this case we have a 2, because a is greater than 0, it's a positive value, we can say that the quadratic is going to open upward, and we call this formally as concave up. This graph is going to be a happy face like such. And the 2 also tells us, because the magnitude of the a value is greater than 1, it's a vertical stretch, which tells me that it's going to be a thinner parabola. Now, what we need to do first is do step 1 would be find the vertex of this quadratic. Step 2 would be to find the x-intercepts, and step 3 would be finding the y-intercept. These key characteristics are going to give us the visual, a good approximation of the graph. It's pretty much the main ideas that we need. So let's focus on these pieces. The h value, right, is -3, and this k value is -8. All right, these two pieces in green are going to tell us where the vertex is. Now, vertex is going to be a coordinate like this. From the equation, I can see that I have an x minus 3. Now, for the x value, just remember, it works a little oppositely. Because it says minus 3 in the brackets there, it's just a opposite way you'd think. It becomes a positive 3. The y value of our coordinate is just as you see it. It's the k value, and it's -8. We don't switch the sign for that one. So only switch the sign for the x value. Do not switch the sign for the y value. All right. Now, for the x-intercepts, as usual, you always, for the x-intercept, let y equal 0. So we're just going to state our equation again. That's 2x minus 3 squared minus 8. Make that equal 0. So now, as I was saying, you need to know your 1 and 2 step algebra. To solve this equation, we're trying to get this x alone. So we got to kind of peel all these numbers away from the x. Now, I'd recommend taking this 8 to the other side first. So because it's -8, it becomes, on the other side, a +8. So you have 0 plus 8. So let's just write this carefully. We got x minus 3 squared equals 8. Okay. Now we can see we have 2 times the x minus 3 squared. The opposite operation of times is division, so we just divide both sides by 2, and we end up getting x minus 3 squared equals 8 divided by 2. And that results in an answer of 4. So now this is where things get a little interesting. Let me just write this again, because we're going to do something to it. All right, let me actually give a little more space for that 4, because we're going to do something like this. We're going to go square root both sides. One little detail we need to remember is to go plus or minus square root of 4. And this comes through an idea. Let's do a little aside here. If, say, I had x squared equals 4, how can I get 4? What possible x values will give me 4? If I go 2 squared, 2 times 2 equals 4. That's one way of getting 4. Another way is we can go negative 2 squared. Negative 2 times negative 2 also equals 4. So you can see how when we do this, we're going to get x can be negative 2 or x can be positive 2. Right? When I put that in here, we're going to get 4 either way. So the way I write this nicely is I'm going to go x, I'm going to square root the x squared. And then on the right side, I need to go plus or minus 4. I need to square root both sides. It's a whole balancing act. And as a result, this and this cancel out. The x squared and the x squared root cancel out to get x. And on the right side, we get plus or minus 2. Those are the answers. Right? I could put positive 2 squared gives me 4, or negative 2 squared gives me 4. So now we have something a little more complicated. We have, instead of this, we've got all of this. We're going to square root that, and that basically cancels out that squared. And then on the right side, we need this plus or minus because, well, we have plus or minus 2 here. And then now we need to bring the 3 to the other side. We have 3 plus or minus 2. So, as a result, we're going to have two answers. We're going to have 3 minus 2, or we could have x equals 3 plus 2, where we get x is 1 or x equals 5. And go back, we had let y equals 0, so that is what we're finding here. We're finding the x values where y equals 0. So we have two different possibilities. Y is 0 when x equals 1. And we have another y-intercept when x equals 5. 1, 2, 3, 4, 5. So this happens in two places. So this makes sense. Because a quadratic is going to look something like this that passes through those 2 points. All right, so that's step 2. We have our y-x-intercepts. We have our vertex and we have our x-intercepts. Let's actually draw our vertex in here as well while we're at it. So we've got 3, negative 8. Let's go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, negative 8. So here it is. So you could graph this equation right now. You can kind of get a sense of it, right? Just try and graph it like this. But let's get a little more. Like, it's hard to kind of say where it's going to be in this region here or in this region here, right? So what we can do is also find the y-intercept. That's why we added the step 3 here. And when does the equation hit the y-axis? Where does it hit this y-axis here? Well, we need to let our x value equal 0, right? Think about it this way. Here's our x. It needs to be 0. Where am I up and down? Where am I here when x equals 0? So our equation becomes y equals 2, 0 minus 3 squared minus 8. All right, so we got 2 times negative 3 squared minus 8. What is negative 3 squared? Negative 3 squared is negative 3 times negative 3 is 9. So we got 9 minus 8. So 2 times 9 is 18 minus 8 gives us 10. So we know that the y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see this kind of fits our quadratic shape. Let me do something here. We've learned about the equation of the axis of symmetry. The axis of symmetry is this vertical line that passes through the x-coordinate of our vertex, right? Boom, passes right through here. So this is at x equals 1, 2, 3, right? Our equation of our axis of symmetry is actually the x-coordinate of our vertex here, right? So here it is. Okay. Let's label our vertex while we're at it. Actually, we should do that. We got 3, and it's at -8, right? 3, -8. Check that. We're good. We've also got our x-intercepts labeled. Let's label those. We've got what were those? 5, 0 here, and we've got this other one here. We've got 1, 0 right here. We also have our y-intercept we just found, which is at 0, 10. And here we are. We've got the graph. Let's go through all these. Whoops, let's do this more clearly. It's always a challenge to do it nicely. That's a little too straight, but I'll try my best to curve it here. Curve it here. See, I'm having trouble here. So because this y-intercept is 3 units to the left of our axis of symmetry, let's go 3 to the right, and we get this other point here. It's going to help guide me as I draw this. So let me actually, it's a little easier maybe for me to go down like this, and let's do my best to show the quadratic. That's not too bad. It should always be a little curving, but it's a decent enough sketch. So given our y-intercept, our x-intercepts, our vertex, we now have the graph of the equation. So this is your process, right? We went step 1. From the equation, we saw the 3, which gives us the x-coordinate. Just switch the sign. It's a negative, so it becomes a positive. Just accept that. For now, I could explain that in another video. And then we've got the 8. As you see it, it's just -8. Just goes there. Boom, into our equation. And then now we go into our x-intercept. X-intercept just let y equals 0. And just solve it algebraically like this process here. And then finally, y-intercept helps us find another point to guide the curve. Let's do another example. We're going to try and find the characteristics of the equation and sketch it. So we've got y equals -1/3 x plus 5 squared plus 12. As before, our first step would be to find the vertex because this is in vertex form. We can quickly see the 5 and the 12 give us the vertex. So firstly, the vertex is that because this is a positive 5, we say the opposite. We say it's -5. And then this 12 gives us the y value as you see it. It just becomes just straight up 12. So the only thing we change is our x value. All right, and then let's go ahead and look at the x-intercepts. So next key characteristic, intercepts. To find an x-intercept, that's where the y value equals 0. So let's let y equal 0. We got -1/3 x plus 5 squared plus 12. That equals 0. So let's first move the 12 to the other side. So we've got -1/3 x plus 5 squared. We move the 12 to the other side, so we got 0 plus, or sorry, 0. It was plus 12, now it becomes 0 minus 12. So let's update that. We got -1/3 x plus 5 squared equals negative 12. Now we need to bring this negative 1/3 to the other side. So what we can do is actually multiply both sides by negative 3, and we end up getting x plus 5 squared negative 12 times negative 3. If you do that, if you imagine I went times negative 3, I went times negative 3 on both sides, you can see how this is going to, the negative cancels out with this negative, and this 3 cancels out with this 3. So that annihilates that negative 1/3 that we have on the left side. On the right side, we have negative 12 times negative 3, which gives us 12 times 3 gives me 36, and the negatives cancel out, so we have this. We have x plus 5 squared equals 36. All right, let's give myself a little more space to finish this up. So we've got, let's write again, we've got x plus 5 squared equals 36. We are going to square root both sides to get rid of this squared. And remember, plus or minus, which results in x plus 5 equals plus or minus square root of 36 is 6. All right, so now, as a result, we've got x equals negative 5, bring that to the other side, minus 6, or we've got x equals negative 5 plus 6, which gives us our two x-intercepts of negative 11 or x equals 1. Those are our x-intercepts. Boom. So we've got x-intercepts at negative 11, 0, and 1, 0. All right. We'll keep that in mind. We have our vertex so far and our x-intercepts. We also need to know a useful characteristic of y-intercept. So let's do that in this space here. So for the y-intercept, and this time we let x equal 0. All right, our equation is now y equals negative 1/3. Our x value is going to be 0 plus 5 squared, and then we've got plus 12. All right, so let's figure out what this is. So we got negative 1/3, 5 squared, then we got to add 12 to that. We got negative 1/3 times 25 plus 12. All right, so 25 divided by 3 is a funny number. We got 25 divided by 3 is 8.3333333333. I can do this in different ways, but let's just do it like this. Know that with fractions, we've got negative 1 times the 25. We always do the numerators times the numerator, which gives us negative 25 over 3 and plus 12. But instead of thinking of 12 as 12, I can think of 12 as, let's go 12 times 3 is 36 over 3. 36 over 3 is 12, right? So this allows me then to go like this, 36 minus 25 all over 3, which is 11 over 3, okay? And this is going to be the same answer you get if you just went straight up in your calculator to decimals. You went negative 1/3 times 25 plus 12. You're going to end up getting something like approximately, let's make these approximate squiggly brackets, 3.67. All right, So this is our y-intercept. We have a y-intercept at this point. Sorry, let's write this as a coordinate. Y-intercept at 0, 11 over 3, or we could think of this as, we could think of it as 0, 3.67 to be able to plot it a little easier. So let's go ahead and put all these points in. We've got the x-intercepts. X-intercepts at -11 and 1. So, boom, right there is 1. And then we've got 1 at -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom, right there. Our vertex, we've got a -5, 12. So we got 1, 2, 3, 4, 5, and -5. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12 up here. So there it is. That's our vertex, right? -5, 12, we're good. We got our x-intercepts. Our y-intercept is at about 3.67. So we got 1, 2, 3.67, just over half. So boom. That all kind of makes some sense. All right, so let's do our best here. So we just go a little bit beyond our x-intercepts here, and I can try and draw a curve. Let me do that again. A little bit too far. Let's go here. Draw one more time here. Boom, that looks pretty good. Our y-intercepts, let's try and hit through, and boom. Not too bad, not too bad. This should look pretty symmetric. I'm not actually a big fan of it. Let's try this one more time. Let's try and make this look symmetric. Boom. A little bit better. Yeah, not too bad. You should see here with our axis of symmetry, you should see both sides looking very nicely symmetrical. So this axis of symmetry passes through the x value of our vertex, which is, our vertex is, what was it? -5, 12. You can see here that our axis of symmetry is just that x value. It's going to be the x equals -5 is that vertical line. Our x-intercepts, let's label those as well. We've got, what was it, -11, 0. And our other one is 1, 0. All right, y-intercept is 0, 11 over 3. This is the sketch of our equation.